So let's take a look at problem number 70, the last one on our review. And here it is kind of written by hand, but we're pouring sand onto a canonical shaped pile at a rate of 2 cubic feet per second. Now what that's going to do is it's going to change the volume. So dV dt is 2 cubic feet per second. So find the rate at which the height is changing. Well, the change of the height is going to be dH dt. And we want to know that when the base is 18 and the height is 6 feet. Now, the base of 18 really refers to the diameter of the base. So make sure you realize that the radius of the base is 9 feet. And the reason that that's important is because it's going to allow us to solve for one of these variables in terms of the other, and that is r and h. Bless you. Thank you. And if we're going to work with this equation, which typically would be given to you, I don't expect you to remember the volume of a cone. The problem that we're going to run into is that it involves r and h. It'd be nice if it just involved h, because ultimately we're trying to find dH by dt, not dr by dt. So here's where some similar triangles come into play. The height of our pile is 6 feet at a time when the base is 9 feet. Now, in general, the height and the radius are going to have that ratio. That is, h over r is going to equal 6 over 9. So if you multiply both sides by r, I get 6/9 r, or better yet, 2/3 r equals h. And you know what? That's not what I want. What I want is r in terms of h. So let's do the other way. Let's multiply up here. We can do it down here. Multiply this by 3/2. Get 3/2 h equals r. And the reason for that is that I can take my volume formula here and replace it replace r by 3/2 h. And then this volume formula will depend exclusively on h. So let's do that. That's going to be volume is 1/3 pi times 3/2 h squared times h again, which is 1/3 pi times 9/4 h squared times h, or better yet, 3 and that cancel. I'm going to have 3/4 pi times h cubed for my volume. Again, what's nice about this is that it just depends on h. And so when I go to differentiate this with respect to time, d by dt, on the left-hand side, I'll get dv by dt. On the right-hand side, we've got to be a little bit careful. This term, h cubed, has to be differentiated implicitly. So we'll ignore the 3/4 pi, because that's a constant. The derivative here is going to be 3 times h to the second power times the derivative of the inside. And the derivative of the inside is my dH by dt. Now let me clean this up real quick, and then we'll put in our knowns and solve for our unknown. That's dV by dt. Let's see, that'll be 9 pi over 4 times h squared dH by dt. Putting in my knowns, dV by dt was 2 times 9 pi over 4 times 6 squared dH by dt. So 6 squared is 36. 4 goes into 36 9 times. I get 2 equals 9 pi times 9 again, dH by dt. That's 81 pi. So overall, I get 2 over 81 pi equals dH by dt, and that would be in units of feet per second. It's linear because height just has one dimension.